everybody. How are you? Welcome. Very excited for another Fireside Chat with our Fubon Center for Technology, Business, and Innovation. My name is Melissa Schilling. I'm a professor of strategy at New York University Stern School of Business. I'm also the director of the Innovation Initiative at the Fubon Center. And I am super excited today to welcome Rama Akkiraju. Rama, you can go ahead and turn on your screen. Rama is a Stern alum. I'm pretty sure I had her in classes. I remembered her very clearly when I saw her recently at Nvidia. Also, Rama was a former fellow with IBM and did, I think, some cool stuff in the Watson group there, which is super neat. She is now vice president of artificial intelligence and machine learning at Nvidia. So could not have a more exciting guest to speak to today. And big round of applause. Thank you for joining us, Rama.
Melissa, it's such a pleasure to be here as a NYU alum and as your student, and coming back full circle to be on your podcast or this fireside chat. I'm excited for what's to come in our conversation.
Well, we are very proud to be able to call you one of our own. I think it would be really awesome if you started first by telling us a little bit about your journey to where you are now, like a little bit about your background, your path that led to the role that you have now at Nvidia.
Sure thing. I started out at IBM Research, Melissa, late 90s after my master's degree in computer science. And I worked at IBM Research for a number of years, working on a lot of cool things in the areas of semantic web. Throughout my career journey, it has been something to do with AI and optimization. That's been my main theme. So I worked on a number of things that while at IBM Research. Then I moved to the IBM product organization, led a number of initiatives in the area, especially when IBM's Jeopardy system, beat the human champions in the game of Jeopardy.
That was exciting. I remember that.
Yes, and IBM formed a new division called IBM Watson at the time, and I was joined as a distinguished engineer in that organization, and also as the director of engineering. Later on, I worked on a number of things related to natural language understanding, speech to text recognition, and number of things in that space, and language enablement, and making AI speak different languages and all of that. I became an IBM Fellow for the work that I had done there. And then I became a CTO for this area called AI operations. So that was my journey in IBM. While I was at IBM Research, actually, a few years into my career at IBM, I felt that I needed to go get an MBA degree, primarily to understand the business side of technology that I was working on. It's not like I wanted to change my career to go into becoming somebody in product management or anything. I wanted to be a technologist, but I wanted to really be able to articulate the value of the technical projects that I was driving from a business perspective for business users, and connect that technology to business. And that's when while I was working, I went to NYU Stern and got my MBA. And I have to say, thanks to you all as teachers, you guys taught me a lot. And I came back with the set of tools and a toolkit that I can apply to my job to really connect, make that, build that bridge from technology to business. And that served me really well throughout my career, thanks to NYU Stern. And just recently, about 8 months ago, I joined Nvidia after having been at IBM all my career. I felt it's time for a change and go do the same thing in a different context, because I'm still very much in the space of AI. I'm here as the VP of Enterprise AI and Automation here at Nvidia. And my mission here is to leverage AI and automation for solving enterprise problems. So some of the cool things that we are working on include things like facial recognition based entry into buildings, chatbots that are virtual assistants for our employees, answering all sorts of questions from IT help to HR benefits to everything else. And we'll talk more about that, hopefully, during our conversation, especially in light of ChatGPT and all. What does it mean to be a virtual assistant and all that? Some of the other projects that we are working on include building cybersecurity models. That is, how do you detect intruders? How do you detect compromised user accounts and take action more proactively and promptly? So these are just a few to name, but basically wherever we can apply AI to solve enterprise problems, and that may include things supply chain modeling. And hopefully we'll get to talk some of those kind of things and even see some cool videos during the rest of our talk. But yeah, that's kind of how my journey has been. But I would say I'm very grateful to the learnings and things that I have learned at NYU Stern.
Well, we're glad to hear that. A lot of people, I'm sure everybody's heard of Nvidia graphics chips, especially for gaming. I know my son lined up one time outside of Best Buy to get the latest Nvidia graphics chip. But a lot of people might not understand Nvidia's position in AI and why Nvidia is actually very well positioned in AI. So could you maybe explain that to people a little bit, how that happens?
Yeah, absolutely. I know a lot of younger generation will know Nvidia as a gaming chip supplier, because they probably have played around with Nvidia chips. But I think right from the beginning, Nvidia had this vision for really driving accelerated computing. And at that time, gaming happens to be the one where that required these most high-powered chips, and so that's the main use case that Nvidia went after. But the vision has always been accelerated computing, and accelerated computing is not easy. It requires full stack invention, right, from chips to systems to networking, acceleration libraries, and refactoring of applications and all that. So from the chips to Nvidia built this whole ecosystem of how do you write programs that leverages these graphical processing units, which are really high-powered computing chips where you can parallelize your work and such. So in order for you to do that, you have to write your programs in a different way. So how do you write programs? And you have to have a programming layer. So it developed this Code Unified Device Architecture, what called CUDA, as a platform, which caught on a lot of attention from academia and students, and everybody started programming and started leveraging it. And then came along the data processing units, where you can actually have business applications move their computes over to these data processing units to do all of the tasks in parallel, and use them for tasks that CPUs can't do. Or you need to have an army of CPUs leveraging so much of power and such. Whereas if you replace that with one NVIDIA chip, you can reclaim some of the power and use those savings for new growth, and you can accelerate your workloads for it. So that's kind of how it came about. And now, fast forward a few years, it took a while for industry and all the use cases to come along to leverage these high-powered GPU chips. Now they are powering every cloud vendor, cloud services provider out there. So if you look at Amazon, Azure, AWS, Oracle Cloud, Google Cloud, pretty much everybody out there use NVIDIA's GPUs behind the scenes for high-performance compute loads. And in fact, in just last week's and this week's Global Technology Conference, NVIDIA has announced a number of more partnerships with all these cloud services providers, where NVIDIA will offer super clouds. That is, you can actually go and get these high-powered GPU machines for rent for your workloads for running them efficiently. Now, the interesting thing, and I'll cite this episode, I'm sure everybody in the audience have heard of ChatGPT. It's hard to miss what's going on in the world of AI these days. Every day there is something new happening. It's getting hard to keep up on the number of announcements Google, Microsoft are making in search, and how many new use cases the generative AI and ChatGPT will power. And it so turns out the first and this whole technology is powered by this wave of innovation called generative pre-trained transformers, in short for GPT, right? That's in the name of ChatGPT. And when OpenAI, the company that put out these GPT models and now ChatGPT and GPT-4 that came out, they wanted, in order to build these models, you need really high-powered chips, and the existing CPUs or the army of CPUs, the cluster of CPUs that you can set up wouldn't have done the job. So in fact, Jensen Huang, who is the CEO of Nvidia, hand delivered the first GPU to OpenAI when their GPT project got started. And so this whole revolution of ChatGPT behind the scenes of how they were able to process trillions of this, language data out there in the public domain to build this model that is able to do so many tasks like summarization, language translation, question answering, and all of that. That is all done these models are trained on NVIDIA chips. So I would say, NVIDIA is set up well. I don't want this whole talk to be about NVIDIA, but since you asked about that, I wanted to mention it. It's set up very well as the provider of, the whole accelerated compute platform for powering the generative AI revolution that's happening out there. And that includes, things in the world of Omniverse, which is all about how do you bring the virtual worlds and real worlds together? How do you model the virtual worlds like warehouses and other things which are in real world, but you want to model them all so that you can really optimize how you manage your warehouses. In order to do those kinds of 3D rendering and complete modeling of your virtual world, and for it to be as close to real world as possible, you need these high-powered real-time, processing compute chips, and NVIDIA is underneath all of those things. So for the next generation, to talk about agriculture, talk about autonomous driving, talk about supply chain management, all these use cases need real-time, high-process compute kinds of platforms, and NVIDIA is set up well to power that. So I would say overall, it's the time of, we're at this inflection point in tech industry where so far it's been going kind of steadily, and now it's a huge step function. With the compute that we have access to, with just brute force, we can do so many tasks, including image generation, video generation, text generation, and with multi-model trainings that you can do. This multitask learning has gone to a point, it's not just about text. You can give text prompts and generate images. You can give text prompts and generate 3D images and videos even. So there are so many use cases, and there will be so many startups, and many use cases can be significantly transformed. And powering all that, you need all these. Not everybody out there can build all these models themselves. So there will be some of these companies who have this budgets to build out these big models, and they will be training on NVIDIA chips. I'm sure there'll be competitors over time, but hopefully we'll be catching up and staying ahead. But there will be some companies who are capable of, who have the bandwidth and are capable of building these big models that are trained, and everybody else out there are able to leverage them in fraction of seconds speed via cloud, and use these APIs for transforming all these use cases, be it in marketing, supply chain, retail, agriculture, warehouse management, all these other domains that we can think of. So that's been the journey of NVIDIA, starting from, I would say, the graphical processing unit in primarily applied in gaming domain to present day, where it's powering pretty much the entire revolution of generative AI. Wow.
Okay, so since you mentioned ChatGPT, which I wasn't going to bring up until later, but I want to ask you about this. I mean, from my perspective, it feels like, having talked, I teach a lot of students every year. I deal with a lot of businesses. For a long time, artificial intelligence seemed like this kind of abstract thing that was used only by high-tech companies, that high-tech companies are working on, but it didn't seem very tractable, and it wasn't in the lives of most people. It feels to me like the launch of ChatGPT changed that. Like it suddenly brought artificial intelligence to the mainstream. I would just like to know if you've seen much of a change in the way people are talking about it, or the kinds of companies that are coming to Nvidia about it. If you feel like there's a sea change kind of being unleashed by ChatGPT because of its sheer accessibility, right? The fact that anyone can get on it.
Yeah, absolutely. I would say so, Melissa. You're right. In 80s and 90s, if you look at the history of it, there's been a lot of academic research in the world of AI, and there were quite a few industrial labs that had robotics as their one of the organizational functions, at least experimenting and such. But many things that were needed to actually productively use them were not ready at the time. There was not enough data to train these models. There was not enough compute. They were hopelessly slow, and it was just, and so not feasible at the time. So academic research grants and other things, they focused more on semantic web and ontologies, trying to represent and trying to reason. And that work kind of continued slowly, but that's like the onset of AI winters, if you will. And many industrial labs actually abandoned their robotics initiatives or major AI initiatives, and then the world went over to business process management, operations research, and more mathematical modeling and statistical machine learning, where you have structured data and you can still of course, you can still do machine learning with regression, logistic regression types of algorithms and such, and that's kind of where the industry was at, mostly structured data. And then there's big data came about and said, there's a lot of data, now let's process it, but still it has to be all structured data and everything. And how do you parallelize it? And Hadoop came along. And so these were all different technologies, and that kind of happened. And then work started suddenly kind of picking up in the areas because the cloud came about, and compute now is starting to become more accessible to everybody. You can rent instead of owning all of this, and then a lot of unstructured data started opening up in public domain, Wikipedia, internet, and social media platforms and all that. And companies themselves always had a lot of unstructured data in documents and everything that they weren't able to harness. But now when slowly the algorithms and deep learning neural networks also started advancing because they now have more compute and they're able to train bigger models and all that. So now then came these models called transformer models, which really kind of triggered this onset of this whole GPT, which basically were able to predict the next word, processing large language models and predict the next word, right? As with training with large amounts of data. And then the compute came along to power it. You started training on large amounts of Wikipedia data in multiple languages. And as more compute came along, then this whole thread of let's put reasoning and other things to the side. Let academics worry about that. Let's actually see what brute force, just scale this whole problem and treat this as a scale problem. Let's see what it does. And then from those transformer models to diffusion models, stable diffusion and diffusion models came along in images and such. These are different techniques and in algorithms and such. But the key point here is that the whole compute that is now available and the data that's available, you put them both together and treat it as a scale problem and say, go at it, go really process these trillions of language documents out there and just by brute force, figure out and understand language. If you can call that quote unquote understanding. And that's what led to this generative pre-trained transformer models revolution. And then those models were doing pretty actually they became multitask learners. By that I mean, earlier we used to build single models for every task. One model will do language translation. You give it in English, it'll translate to French, and you have to train that with all the data, English and French, parallel data, translated data sets, and it'll learn. Then you build another model to understand people, places, and things, the entity recognition model as a separate model. So you keep building these multiple models, and these GPT models came along and said, let's actually throw everything together. It'll understand the language and call everything to be predicting the next word in the sentence problem. And then we'll put everything as an instance of that predicting the next word in a sentence. And it has shown great progress. The results were quite good, but not as good as ChatGPT. And ChatGPT came along and said, these GPT models are good. Let's actually take some human feedback. Humans guide with specific prompts. Here is a question, here is an answer, here is a question, here is how to answer, here is the style to write a good essay. There has to be a beginning, middle, and an end, and the connection between how the process should. So humans wrote all that, and now it became, when you fed that in, came to present day's ChatGPT, where human feedback really helped improve it, take it to the next level. Now we have all these multitask learners. So going back to your question, why is it more accessible? Earlier, it was more for researchers and who were trying out specific tasks and such. But now the language understanding, again, it's not truly understanding. People will argue, you can have philosophical debates about it. But for all practical purposes, in many cases, it's exhibiting the science of understanding just through brute force learning of statistical relationships between words. And because it's doing so well, now you can imagine students can give it an essay and say, paraphrase it for me. And people who are writing their documents or emails, you can put it in there, say, help me correct grammar. And marketers and sales folks can give prompts and say, generate my initial draft for me. And with the multi-model learning, the models that are coming up, now you can say, give a text prompt and say, generate my PowerPoint slides for me. So of course, now it has opened up to a point where everybody out there can find some use or the other in their day-to-day activities, in their jobs. So the fact that it has had 100 million users in the first few weeks in itself shows how many people actually came to know of it and tried it. So yeah, I mean, now it's because the use cases are so wide-reaching and everybody can find some use for it in something or the other. Now it has come to really become very accessible to everybody out there, not just to some researchers. Sorry, that was a long answer, but I also kind of took you through the journey, at least from an industry perspective, sitting as somebody who's been in this journey, what all we went through as folks in the field of AI to get to this point. Hopefully that was helpful context as well.
Yeah. So well, gosh, there's so many questions I want to ask you related to that. I'm going to first ask you, so what industries do you feel like came to AI fastest, that started adopting it most aggressively in the beginning? And what are there industries that you feel like haven't really started using AI that probably should? Maybe, and that it's kind of a tough spot to put you in. If you don't have an answer to that question, you don't have to. I just thought I can
just tell you from my perspective, right? Initially, customer support domain is the one that it's not a specific industry per se. It's more sort of a cross-industry use case. But with chatbots, that was the first use case that really caught on, because people were starting to build, basic models of, can I understand the intent that a caller is calling the customer support agent with? If I understand that intent, I can program specific answers to that, either guide it through some kind of a dialogue tree, or do back behind the scenes, like how search engines do, search through my enterprise knowledge repositories, find the right document, and either serve that to the customer support agent, or to the end customer who called directly, kind of a thing. So that I would say that the cross-industry use case is the first one that really caught on. Many people used, and I'm sure all of us have interacted with chatbots at some point or the other, and we had our own share of frustrations because it wasn't so good. They weren't so good. They weren't really understanding things that well, and then one had to pare down the expectations to say, focus really on the most frequently asked questions. Let's actually get that one right instead of trying to solve everything out there, a complex understanding, language understanding, and all that. So that's one. A lot of efforts got started actually right around that time to go after healthcare domain.
Oh, wow.
But the initial ones, some niche ones like the speech recognition in healthcare domain was quite useful and successful for doctors dictating their notes, and it takes notes and summarizes it and captures it as notes in the system. Those tools came on board, and from previous handwriting recognition days to speech recognition, which became quite good at least in some languages, with word error rates being very low. So in very specific points in healthcare domain, I would say there were successes, but there were also humongous disappointments in healthcare domain because the problem is so big and the expectations were so huge. But now it's coming back again. If you look at ChatGPT, it has shown that it is able to pass the medical tests, the law tests, SAT tests, and all of those things, as an average student level. And even GPT-4, the latest model, is demonstrating things at the level of top 10% of students. So I think there will be huge upsurge in experimentation and leveraging it in legal domain, in healthcare domain, in education domain for teaching. Khan Academy is the first one that's signed up to use GPT-4 to create tutors, online tutors. So these are all new use cases that are going to come up. But if you ask me, you were asking specifically about which use cases came along, I would say, they were tried in personalization, in entertainment and media. So, like you could argue, Netflix and Amazon's recommender systems were all, previous iterations of not so much on unstructured data, but still of use cases. But more interesting things will come. So I would say retail, entertainment, media and entertainment, healthcare, financial services are also very actively experimenting with their enterprise data, all the legal documents and contract understanding, insurance domain. These are all companies in these domains who started various projects. But I would say the progress has been kind of slow and the successes have been somewhat, I would say, mellow. It's not like a silver bullet and it's 100% accurate, 98% accurate, and I'm ready to go. That's because we didn't yet get to this point of where we are today with GPT models and ChatGPT. But now that we are here where we can actually get really unleash the power in unstructured data in enterprises, there will be many more use cases in many industries that will, I think, marketing, sales will change significantly, and content creation, wherever that may be, will change. Advertising will change dramatically. Pretty much every industry will get a boost if they are willing to try this out. It will take some time to experiment and to get to that point, but the power and the promise of transformation is there, and there will be many startups who will go try out these things in pretty much every industry that you can imagine.
Wow, that's so cool. Before I ask you my next question, I'm going to remind everybody that we have a Q&A box. So if you want to submit your questions, when we switch over to Q&A, we'll be able to call on some of those questions. So please put your questions in the Q&A box. But before we do that, I'm still going to take advantage of my opportunity to ask you some of my questions. I got two more questions I really want to get to. One of them is, and you can decide which one you want to answer, or both, if you can answer them both. One is, what have been your biggest surprises along the way? Things that maybe you didn't anticipate, or that took off faster than you thought or slower than you thought. And then the other question is whether or not you have some of the same worries about artificial intelligence that Elon Musk has. He was one of the early not early, but early is really a subjective term in this space, but is one of the people who has talked about the dangers of artificial intelligence. And is that a concern that you have? So either one of those or both, I would love to hear your response to.
I would love to answer both. Biggest surprises. I would say the ability for brute force learning to get to this point where it is so good at multiple tasks in language-related tasks has been, I would say, has been a surprise for me, and I'm sure for many, because image processing and speech have been studied, and there have been a number of years of work that went into image understanding and speech, and we knew that they were getting better and better, and they would get to a point of real feasibility and where you can deploy them in production environments and leverage them, and they were showing a lot of promise. But language understanding is a hard problem because it's human language is filled with so many kinds of things, not just about what is explicitly stated, but implicit, and so many nuances and innuendos and humor, sarcasm. And we were going about it at a pace trying to understand, with the grammar aspects of it, the syntax aspects of it, can we really understand the noun and verb in a sentence and the relation of it and who's the object, and we were kind of going about it that way in one aspect of natural language processing. And one other aspect of it was really going deeper into understanding the semantics and codifying the rules, human ethics, and the relationships between, physical space and objects, teaching that logic and those sort of things, you can call that neurosymbolic logic. So a lot of this work was going on, but it's been slow because it's a hard problem. And then came along the brute force approach, right? It kind of came, come with compute, with the transformer models and some of these advancements, and said, I'm going to throw all of this text at it and let it figure out internally with very deep neural networks with trillions of parameters or billions of parameters. And we have really not that much understanding of how exactly it's learning all that, other than to say that it's doing forward propagation and backward propagation and learning those things. But the end result of it is mind-boggling, that it can understand so many different tasks and prompts and exhibit this ability to understand language and do these tasks to a level that's looking quite promising. That is a big surprise, really, because it kind of...
Can I ask you a question? Is that kind of how children learn, right? Because we don't actually tell children all the rules of language when we start. We just expose them to so much language, and they make associations, and they're weaving together those associative networks that help them decide what means what. And it strikes me as being very similar in a way.
Yeah, that was the original intent of the whole neural networks. They were really modeled after our brain and neurons and such. But the difference, though, here is that these systems still need large amounts of data as opposed to humans. I think human brain is still a lot more efficient at learning from small amount of data. Yes, we expose them to a lot of language, but that's really, if you look at a child from 3 to 4 months to the time 1.5 to 2 years when they're speaking, they got exposed to parents and people in their network and limited amount of language that they're hearing in a day, versus these models. If you just exposed only that much to these models, there is no way that they would learn. So there is something about humans that is still far superior to any of these brute force models that we have built. And that is still good to know. And it gives us hope that we are still more efficient at learning, at least in some ways, on some dimensions. When there are large volumes of data to process quickly, of course, computers can do a much better job than humans can. If you throw a lot of medical journals and ask a medical student to read them all to figure out, how to diagnose, that would be way too much for a medical student. Whereas if you throw it at, computer, it can process all that data and really narrow it down to the symptoms and probably diagnose the problem. So, once it has learned, it's good at processing that data. But to learn, it needs a lot more data than humans do. So you're right in pointing that, where we started with neural networks is really modeling that human brain. But there is still something far superior and efficient about the way humans learn than these models in terms of the amount of data that they need to see to learn. But yeah, I hope that answered my biggest surprise question. To your point about, do I have some worries? I think that AI revolution is unstoppable. There is no point in worrying about it. We just must prepare for it with proper guardrails, right? Fairness, ethics, and standards, and build it because it's already happening and nobody can stop it. So with proper guardrails, regulations, and ethics, we can really leverage it for the good of the society and for the advancement of industry and businesses, and we then have to find higher ground where we can use human brain power to innovate. But there's no stopping it, so we might as well stop worrying and prepare for it.
Wow. I'm often struck by the inefficiency of having a human grows and learns and invests heavily in education and maybe develops some expertise in a particular area, and then eventually dies, and all that knowledge, most of their knowledge, just goes away with them, and new humans have to start from the very beginning again. That strikes me as incredibly inefficient compared to, I think in artificial intelligence, I think with computers, they can replicate that knowledge across, they don't have to relearn it. You know what I'm saying? Does that make sense?
Yeah, I think that's a very, very interesting point, Melissa, you're making. I think we learn as a society on and build on each other's work, yes. However, every individual that's born needs to kind of learn from addition, subtractions, multiplications, long divisions, and mathematics all the way to calculus and then on up, or whatever field they're in, and that has to start from ground up. And so every individual's journey has to go through that whole learning. Although there are papers that you can read and articles and that you can build on, but as we advance more and more, where do you start? Do people still learn assembly programming these days? No, they start directly, probably at higher level programming languages like Python today. And tomorrow, maybe there will be more natural language-based interface to even write code that then automatically will instruct computers to do so. So we are kind of building on each other's thing as a society, but you're right. Every individual's journey is kind of still very personal, and it has to go through it from scratch. Whereas with these models, you as long as you have the compute and all this data that's continuously available, you throw at it and it learns and it can keep on building. So in that sense, there is it can learn a lot more in its model's lifetime, I suppose.
It's immortal, basically, right? It's like, how smart could a human get if a human were immortal? And I still think the human would be limited in some ways compared to the computer, because the rate at which we can absorb input and process it, and also our recall of it, is imperfect, because they're all constrained compared to computers running on super clouds. I'm going to save that. I'm really excited about that word now, super clouds. We could talk like this for hours. I'm sure it's so interesting, but I want to make sure that I get to some of these questions that are accumulating in the Q&A box. So the first one I have here, this is one most professors have thought about. So ChatGPT has been a shortcut tool used to develop research papers and other documents, but will AI tools also learn to detect what is non-human work and detect fake videos? And if somebody submits their essay written by ChatGPT, will I have a version that can turn around and grade it and tell me that it was written by ChatGPT?
Someone actually already built that such a model. I think it might be possible. Again, there will be some issues with accuracy with all of that. But yeah, there are both sides to it. There is a technology that's available. You can use it to aid you in your job to improve your productivity, or you can use it to circumvent your learning and cheat. In which case, I suppose you are cheating your own self, as in you're depriving yourself of that learning, right? If a student were to use ChatGPT to write an essay, if a professor does not detect that it's written by ChatGPT, they get good grades. Yeah, okay, you go get a good grade and you get a job. But how long can you continue to really excel at your job if you haven't learned the basic skills and tools and to use your brain to do that? So yeah, there are some philosophical questions there. But can bad actors use it, or can people misuse it for fake news generation and fake images and all that? It's already happening. Would there be detectors for it using AI itself? Yes, there will be. Would either of them be perfect? Maybe, maybe not. But there is no denying that that's going to be the world that we will all have to live in. So the question then really becomes, how do we as a human society address it? How do we tackle it? How do we put guardrails around these things? How do we, what portions of it would we regulate, and how do we deal with it legally when misinformation is getting spread purposefully? Is a totally new domain that we are all getting into. We just have to find ways to work with it and deal with it, but we can't stop it. Even professors or teachers asking students to not use ChatGPT is not going to work because students will find some way of using it. So they have to get more creative now of how to frame their assignments and exams in a way that it actually tests their thinking abilities, as opposed to some of these other things that AI can do for them. So it's new ground. I don't know that anybody has answers to all of these things, but very good questions for sure.
Yeah, it's kind of a race, right? All right. We've had a pretty long question here. I think this question boils down to asking your chips that are powering all these applications, they keep delivering more computing power for a given areal amount of silicon. But given that we're approaching the physical limits of shrinking components, how are you guys, what are the state-of-the-art technologies being developed at NVIDIA to address that? Like, do you think we're going to hit a point at which it's going to get a lot harder to increase computing power because of physical limits?
That's what we've been thinking. Moore's law has been guiding how much progress you can make, and the industry has been tracking that. But every so often we find out that you can pay it up. Okay, when you reach physical limitations, you put more things as nodes and clusters and put that compute cluster to job by writing software platforms that will then distribute these computes across these multiple chips, right? If one chip can't handle it. So I think we'll continue to do that. I mean, the chip technology itself will continue to evolve until it hits physical limits. But we've already figured out as a computer industry that we can, if one is not enough, you put many and figure out a way to leverage many seamlessly. So the end users don't know about it, and the programmers have enough platforms and tools and integrated development environments to make it easy for them to distribute their loads, without having to go write all this code every single time. So there are ways in which we have found ways to scale, and that's in many ways, that's what cloud computing is all about, that they allow you to scale up and down and leverage how much ever based on the task and workload requirements.
Okay, cool. Let's see, hold on. Anurag Gupta asks if you can comment on artificial general intelligence, if and when we might get there, and should we?
Well, in many ways, again, I don't want to, it's my personal opinion, we are already kind of making our way to that that goal. I'm not saying we are there yet. We've long ways to go. On some faculties, these models exhibit pretty good, comparable to human, or even better in some cases on some of these tests. These tests being what earlier in the field of computer science used to be called Turing test, right? Where you don't know the difference between a human or a computer who is answering or conversing with you on the other end. And if you look at some of these tests that these systems are able to take, either LSAT or SAT or other medical exams and such, and in the field of radiology, and in an individual of those tests, it seems to be doing as good as an average student, or even sometimes showing up in top 10%. If these metrics are a measurement for anything, we are making progress for sure. Are we there yet with real understanding of reasoning, of understanding of the relationship between the physical world and the real world, and objects in the physical world, and do real reasoning? There's a long ways to go for that. However, there is still quite a bit of stuff that we can do even without having to have full artificial general intelligence, with the narrow AI, and where we are with all the advancements that the tech industry has been able to make. So we don't have to wait for it. We are making our progress to it. Will we ever get there? Who knows? But I think we are definitely at a point where we can put AI for many use cases, for many use cases, and significantly improve our productivity in many use cases. So it will be transformative.
So forgive me for not being an expert in this area, but when a telemarketer calls me and it takes me 10 minutes to realize it's a robot, is that like a successful Turing test?
Well, it depends. If that 10 minutes is like how the conversation would have gone with a human, maybe so. But if it is asking you tens of questions because it didn't really understand what you meant, and asking repeatedly those questions, then I would say no. But if you're not able to know the difference between, if it is smart enough to build on the conversation and ask you right questions, and is actually taking those right questions and steering the conversation in the right direction, I would say for that task, it is exhibiting the behavior of general intelligence, artificial general intelligence. But can you extrapolate that to say now that's the same system is just as good in understanding legal documents? The same system is just as good in interpreting somebody's, say, blood test results and diagnosing problems.
Or even know if I'm telling a joke, right?
Yeah, and you're right. But at the same time, I would also say, is that even a right test to put an AGI system to? Because even in humans, there is nobody who is a legal expert and a medical expert and an engineer and a jokester and everything at the same time, right?
True. My kids are telling jokes all the time, and I have no idea that it's a joke. All right. Christopher Navarro Barajas asks, since ChatGPT brings many ethical and legal concerns, how should companies use it to be socially responsible and maintain the strong brand that they have? Since artificial intelligence will deliver great value for companies, what limits should they set to not create unhealthy competition and impose long-term consequences on society? I guess he's asking you a little bit about these guardrails. Like, how do we decide what these guardrails should be, and are they going to work?
Yeah, I mean, it's an important question, interesting problem, and I would say it's work in progress, because we know, we've seen with the New York Times article, I'm sure many of you have read, Recently, a reporter had chatted with Microsoft's new Bing, which had the
And it got really
GPT-4.
creepy.
It got creepy, and it got into random zones and got love struck towards the end. And so you could argue, because of all the peer pressures and such, they went ahead and released something that is not fully properly tested, evaluated, and put in all the guardrails put in place and all that. But yes, that's true, and more of that work needs to happen. And there, you do as much as you can, but at some point you open it up for use cases, and these use cases and in open domain will test the limits, and there may still be things that it will do that are not appropriate, not factually correct, and probably silly or crazy or sometimes even harmful. And that is where I think we have to really find ways to apply our own common sense and when to use, when not to use, especially when these kind of things are used in any kind of counseling, guiding, influential roles that impact people's mental, physical, and financial well-being. You want to be extra careful because they'll have very important, significant ramifications on people's lives. How do you do it? It's a combination of a lot of things. It's a combination of tech companies themselves implementing those guardrails, first of all, and it's for everybody who is using it to really set expectations on what use cases it can be used for and what use cases you would only try it as experimental, and for regulators to really also regulate some of these things where applicable, especially in financial, medical, and mental kind of domains, right? So all of these things have to come together, and there have to be, I'm sure there will be, and there already are many ethics bodies that are looking at what does it mean to have these AI models that are fair and not biased and are ethical. There are a lot of these things that are still work in progress, but that shouldn't stop us from using it in the use cases where they're already going to be significantly productivity boosting and efficiency boosting scenarios.
Okay, so I think it's related to that. Vincent Lau asks, what are your thoughts on AI replacing humans in professional jobs such as teaching foreign language or creative writing? Should students be pragmatic in avoiding studies in these areas if they're going to be replaced by AI? And I want to add to that, because when I came to NVIDIA about a month ago, your colleague said something that I've been anticipating coming for so long, and that is that your colleague said, we don't really need programmers anymore or we won't need programmers soon because computers will do most of the program, as many programs say. The computers are going to do a lot of the programming for us. Artificial intelligence is going to do a lot of the programming for us. So what is your take on jobs that maybe we won't need anymore or as much of, or maybe there'll only be room at very specialized high-end fringes of? Pretty big question, actually.
Yeah, I'm sure in some areas, there will be significant productivity enhancements for people. And in some cases, there may be displacement of jobs. If there maybe you don't need as many people generating your campaigns or managing your campaigns or in marketing or in content generation and such. People start use tools like ChatGPT, and it'll do a good chunk of their first draft work type of thing. So, but there probably will be displacement of jobs or reduction in jobs in certain areas. However, I don't think we're at a point where we don't need programmers anymore, especially if you're talking about programming. There is a lot of programming help that ChatGPT like tools are going to give, and it is already giving. GPT-4 is even better than ChatGPT already, as demonstrated in their video. And many tools are already incorporating these kinds of co-pilot, code helper kind of things. But they're not there at a point where you can start from scratch, take high-level requirements, and build out the whole fully functioning thing, and be able to have these autonomous IT systems where they they've been programmed automatically from the requirements. They've been deployed automatically. They've been able to monitor themselves if there is a problem, fix themselves up if there is a problem. That's a vision. We're not there yet. Are we making progress towards it? Yes. Will we ever get there? I don't know. We definitely are getting to a point where there is more automation, AI-driven automation in many of these many areas, including code generation. In some cases, there might be reduction of jobs and roles. So the future of work will be different. Definitely, people will find out as things unfold as to where majority of these use cases are sticking to a point that the productivity gains are so significant that you have to think about your next generation of jobs differently. Definitely, this conversation should happen to be prepared for what kind of things should we be teaching students in universities and colleges to prepare for the next generation future of work. Definitely, they need to be aware of what's going on and be able to leverage these tools, because anybody who is able to leverage them will be more productive. Anybody who is not able to leverage them, any company or even a student writing an essay, will be probably at a disadvantage. So we just have to figure these things out as we go along as to where we end up. Yes, there will be changes. Yes, there will be displacement. Yes, there will be productivity boosts. Yes, there will be change of roles and future generation of roles and jobs. Maybe there will be more designers needed as opposed to programmers, because we haven't gotten to the point of that. Even in design and the world of art, we are getting to a point where things can be generated, but slowly we are shifting more and more left to the more creative tasks as well with AI. So again, these are all good questions. I don't have silver bullet answers. These are all things that everybody in the industry are asking themselves, debating, having discussions, and figuring out as we go along.
Wow. Yeah. All right. Oh my God, we've only got 2 minutes left. I'm going to ask you, I have a question I think could be answered here easily. All right, I think this one will be pretty easy for you to answer, hopefully. What are the skills, Maj Abi Ali asks, what are the skills required by individuals who want to take advantage of the newly launched Nvidia AI Foundations to develop their models? And what's the best way to obtain those skills?
Best way to obtain those skills is to play around with them. I mean, if you are at a point where you have enough of the background to play around with these foundational models, they're available. They'll come with toolkits. They'll come with examples. They'll come with all the paraphernalia that you need to get started. So best way to do it is play around with them. These foundational models are, as the name suggests, they're foundational, as in you can start from there and they'll give you like 75% or 60% or even 80% of what you need to start with. And then you bring in your specific use case, your data, your requirements, and fine tune these foundational models to specialize them for your needs and leverage them in your enterprise. In fact, that's exactly what we are doing internally now, leverage all the foundational models that we have access to and train it on specific, in company-specific data around HR benefits, IT help, these kind of or Slack conversations that employees are having amongst themselves, or coding questions or Stack Overflow kind of things where people are asking questions. You kind of take it to your specific use case and the data that pertains to that domain and fine tune those models. But a great place to start would be to start playing around with them.
Okay. You know what? We ran out of time. We have so many other questions here. I'm going to try to capture these so that I can at least send them to you so that you know the kinds of questions people are asking. But I want to thank you so much for coming. You are amazing. I hope that we get to have you back here again. So thank you, Rama.
A pleasure, Melissa. Thanks for having me here. Good to be on with you on the Fireside Chat, and thanks to all the participants who asked such interesting questions as well.
Yeah, even the ones we didn't get to. And I want to remind everybody to come. We've got we've got the FinTech conference coming up. You can attend that. I believe that's April 21st. We have a bunch of other exciting stuff. If you can go to our website and see our upcoming events. So thank you for joining us, and we will see you again soon.